In this lesson, we're going to look at just some standard formulas and percents. Now, formulas are just equations that fit particular instances, a lot like areas of a triangle, circle, volume, just general formulas. You see them all the time in your science classes and physics, chemistry. In fact, you see them everywhere. Now, one of the things that you're going to be involved in with your formulas is going to be solving for specific variables. A lot of times for areas of triangle, you were given the formula for the triangle, given the base and the height, and wanted you to find the area. We're kind of working backwards in that suppose you were given the area and the height, you need to find out what the base is. So how do you go about solving that? So whatever formula you use, you're going to go through 3 steps to solve for whatever variable specifically that you're looking for. Step 1, clear fractions. Very similar to the first steps that we did, clear fractions and decimals, when you're solving an actual linear equation. In this case, this is like helping to solve and isolate whatever specific variable we're wanting to look for. Step 2, we need to make sure all terms with a specified variable are on one side. That's very similar to our other step, where step 2, have all the x's on one side. In this case, whatever variable we're looking for, base, height, radius, whatever it is, we need to make sure it's always on the same side. So we're just moving it over, and then you divide both sides by the coefficient of the specified variable. In other words, that's kind of a combinations of step 3 and 4. Now that we've got all the terms on one side, we want to get it isolated. So that way it's all by itself, and we have whatever variable we're looking for is equal to the rest of the formula. So we're going to look at, as an example, one general formula that you'll be going over in your homework and example problems is, of course, the area of a triangle. Everybody knows the area of a triangle. I'm sure you know it from geometry. Area of the triangle is 1/2 the base times the height. We've seen this before. You've probably seen it in elementary school. You've seen it in middle school. So we know area is 1/2 base height. So suppose that we're wanting to solve for the particular height. So in this case, we start off with 1/2 area equals 1/2 base height times height. So step 1, we need to clear fractions. Easiest way to clear the fraction here is to multiply by 2. In this case, because as you can see, you can say we're dividing by 2 on this side. So if we multiply by 2 on both sides, we keep the equality and we get rid of this fraction. And this simplifies down to, now we have 2 times area equals 2 times 1/2, which is just 1, kind of goes away, base times height. Now that we've already got height all by itself on one side, we need to get rid of the base, the b. So to do that, we divide both sides by b. In this way, we get divide by b on the left, divide by b on the right, so our equality is still holding. But now our b's, because we have a b on the numerator and the denominator, they're going to just cancel out. So all that's left is just h. So we have h equals 2 times the area divided by the base. And in this way, this is almost exactly the exact same steps you would take to say if you were wanting to solve instead of for the height, you wanted to solve for the base. You can start from either equation actually and make it. Probably want to start back off again at the very top and work your way down. Another formula we're going to be using a lot is the interest problem. When you put money, you put it in a savings account and it accrues interest over time. In other words, you gain extra money just from it sitting in that savings account. And this is known as the interest principal rate time equation, or IPERT is what some people call it, where I is going to be the interest, the amount you've made or earned. P is short for principal. It's really just another way of saying the starting amount. What you start with. R, of course, is the interest rate. This is always in decimal form, so the interest rate, if the interest rate is, say, 4%, then in your equation, you're not going to plug in 4. You're going to plug in 0.04. And then, of course, you have T is time. And in our case, time will be in years. So after 1 year, then T will be, of course, 1. After 2 years, T will be 2, etc., etc. So suppose we wanted to solve for time. Say we know what how much interest we want to make, how much money we're starting with, and what the interest rate is. And we want to know how long does it take for us to earn a certain amount of interest, I. So in this case, we're solving for time. We're wanting to isolate time all by itself. So first thing we want to do is we're going to isolate T. So we're going to look at P and R as one number, or the coefficients of T. They're what's in front of T. So the easiest thing to do here is combine into a single step. We're going to just divide both sides by PR. Of course, our initial cautious tail, P can't be 0, R can't be 0, and P and R can't equal 0. P times R, which obviously means P can't be 0, R can't be 0. So in this case, P and R, they sort of cancel out, and we get time all by itself. So now we have T is the interest we're wanting to make divided by what we started with and the interest rate of that whatever the savings account is. The third formula we're going to look at here that you see a lot, in fact you see a lot of it in early physics classes, is the distance formula. Distance equals rate times time. So distance, of course, D, very simple. R is the rate of speed. This could be miles per hour. In physics, they like to do meters per second. So, and T is always time, whether it's in years, hours, minutes, etc. Now, one thing to be cautious about is time should always be in whatever the rate is. And what I mean by that is, if the rate is, say, miles per hour, then that means T needs to be hours. You need to make sure that the time that's related within the rate of speed is the same as the time used in how long it took. So in this case, we're going to have, so in your physics class, you'll have meters per second. Then that means T should be in seconds. Or if they give you time in hours, you need to convert it to seconds so that way it'll match up. Otherwise, you're going to have, technically you would have like distance equals a rate of meters per second with time hours. You're going to have meter second hours, which doesn't help you. That doesn't tell you a distance. You need to convert the T from hours to seconds so that way they cancel out and you're left with just meters. So in this case, say we know how far we went and we know how long it took us. We want to know is what was our rate. So everything's already simplified. So what we need to do is we want to get rid of in this case, the time. So the easiest thing to do, since they're multiplied together, is to do the opposite step, which is to divide. So we divide t, time, from both sides, and the t, of course, here cancels out, and you're left with a rate is distance over time, which should make a lot of sense in how we measure it, and just by listening to it. Cars travel in miles per hour, a distance per time. In physics, and speed of light is always measured in meters per second. So, in other words, light will travel 3 times 10 to the 8th meters in 1 second, which gives us a rate of 3 times 10 to the 8th meters per second as the speed or the rate. Now, another area that we're going to be that we cover is percent, which we sort of covered in got introduced to you in that interest formula. For percent, 1% is the equivalent as saying 0.01 or 1/100th. And in fact, that is almost the literal translation of the word percent. It is per cent or per 100. And so 1% is 1 per 100, or 1 over 100, 1/100th. Now, to find a percent of something, you need a partial amount divided by the base b, which in most cases, that'll be like the whole amount. Like if you want to know how many slices, if you took 3 slices of pizza and there's 8 slices to the pizza, what percent of the pizza did you eat? Well, that would be, your partial would be 3 slices, and the base is the total, which would be 8 slices. How many slices are in the whole pizza? And so you get 3 divided by 8, and you get a percent. And that will be written either in decimal form, 0.3775, or it'll be in percent form, which would be 37.5%. Now, another thing you're going to look at is percent change. This is how much something has changed based on what it was initially. This is done by, again, the amount of change divided by the base, or in other words, the original amount. Whatever it was is what you're looking at. You always consider from when it comes to percent change. You never look at the new amount when finding the base. You always start with the original. Now, this amount of change can be positive or negative. So it's always new value minus the old value. That's how much it changed. It could be that it went up. So it could be that it went from 100 to 110. So that means you had an amount change of 10. But it could be the opposite. It could be you started at 100 and you went down to 90. So your new value, your change will be 90 minus 100, so you get a negative 10, a negative percent change, or a percent decrease. If the new value is larger, this will be positive, and that is a percent increase. Now again, click on any of these links for you to review any section that you feel that you want to relook at or refresh yourself. As always, if you do have any questions over any of the review problems that are on the website, feel free to post any comments, questions, or concerns here on this video on YouTube, or you can post them at the bottom in the forums on the website. That's probably going to be a little bit easier on the website because it's a threaded discussion. You'll be able to see what everyone says and everything. So, use your time well, and I will see you in class the next, and whenever that is.